Criminal Recidivism After Prison and Electronic Monitoring by Rafael Di Tella and Ernesto Sharkrowski. The main question of this paper is, does recidivism rate changes if individuals are released from prison or from electronic monitoring? And the main contribution is providing estimations of the effect on recidivism of having a prisoner serve time under electronic surveillance instead of prison. The data they use is from Buenos Aires because this was the first place in Latin America when an electronic monitoring program was implemented. The paper starts by describing the situation of prisons in Buenos Aires, a city which hosted a population of 30,721 inmates in 2005, which represented the 44.5% of the total population of inmates in Argentina. The conditions of confinement were extremely poor, there was lack of food and hygiene, and in some prisons there were neither ventilation or sanitation services. Also, most of the detainees are located far from their relatives, so they can get food or hygiene products, which makes the situation even worse. Because of this, the EM program started with 300 bracelets, with almost 20 officers to supervise them. At the beginning, these bracelets were supposed to be granted to the old and terminally ill for them to spend their final days with their families and in their homes. But in the practice, this rarely happened, and individuals accused of serious crimes such as rape or murder qualify for the use of EM. In the paper, they also specify about the types of judges. In Argentina, there are two extreme judicial positions, the conservative and the liberal. Liberal judges are the ones who consider whether prison or EM, and conservative don't even consider the option of EM program at all. For the EM assignment, they created this model in which X are the characteristic of the defendant, and the judge has to decide on pretrial detention or EM. If the judge assigns EM, the probability to escape is P, and if that happens, it will cause harm to others and a cost for the judge of H. But if the defendant is in a prison, there is no risk of escape, but the judge experiences a utility differential that is D, when he sends someone to prison who could have been treated less harshly. So in other words, D captures the judge's ideology. The defendant will be assigned to EM if the equation is satisfied. This equation also has three implications. First, if D is positive, the judge will be conservative. Second, with D constant, if the use of EM decreases, the probability and the cost of escape will decrease too. And third, with X constant, the judges have different preferences of punishment, and this creates differences in the use of EM. They compare recidivism rate of the EM and prison population running this model, where R is a dummy variable that indicates whether individual I went back to detention after his release, and EM is a dummy also that indicates whether individual I was in the EM group or not. The main concern is that judges try to assign EM to individuals who are, like they say, a kind type, or have lower risk of committing a crime after his release. But because this is unobservable, in the OLS estimation, they use an instrumental variable, which is the judge's ideology, and they also introduce another dummy variable for whether the judge has previously sent a defendant to EM. The results they found were that the recidivism rate when people goes to prison is 22.37%, and the recidivism rate for people who use the EM is 13.21%, with a difference of 9.16%. Because the period of likelihood recidivism is different for each individual, they use an average of 2.85 years. In this table, they use OLS regressions and they got those results. In column 1, they run recidivism on a dummy, indicating if the person was released from EM. Column 2 presents a regression including year dummy, if the defendant is Argentinian or not, age, type of crime, and number of previous imprisonments. Column 3 repeats the same regression as column 2, but with a probit regression. Column 4 reduces the sample to defendants accused of aggravated robbery, which is the most common type of crime. In column 5 is an indicator of whether the judge has ever used the EM program. With this, the concern of the judges that I said before of assigning EM to individuals that are classified in the kind type should be represented in the estimate on the dummy of the judge using EM, and should be positive, but instead is minus 0.2. So the implied estimate of the difference in recidivism in prisoners who stood before the two types of judges suggests that there was no selection on part of the judges. In Table 5, they use the judge ideology to estimate the effect of EM on recidivism. In column 1, they use dummies as an instrument, although it has limitations because the length of the sample, that is, 172 judges. In column 2, the instrument is a percentage of defendant that the judge sent to electronic monitoring, which is highly significant. The coefficient to EM is still negative, but it is a little bit larger than in the OLS estimation, which implies the reduction of the raw recidivism rate for people who went to prison. In column 3, they added how much did the judge last to use the EM program. Both instruments are significant and show a negative effect of EM on recidivism of minus 0.16. In the fourth column, they combine these two instruments on an IV profit regression with a similar result than in column 3. In column 5, they took the same regression as in column 3, but not with the same sample of 1,503 observations. They used a full sample of defendants where EM bracelets were actually assigned. Then they used the predicted EM assignments for the full sample and used it as an instrument for EM in the recidivism sample. This shows a negative and significant effect on recidivism of 11% approximately, which represents a drop of the recidivism rate of the prison sample. In this table, they used the EM sample, and in the first column, they included a simple OLS regression of recidivism on the amount of time under supervision with EM, revealing a negative relation, but it is not significant. In column 2, they used the same regression, but without the amount of time under supervision. Within the sample of 386 individuals, 17% fled from the penal system by breaking their electronic bracelets. These escapes occur at a lower rate of the group that never went to prison, that is, 20 defendants, than from the group that spent some time in prison, that were 46 defendants. Instead, there are no registered escapes from prison in the sample, but in the sample they included when an individual escapes and it is arrested again, and it counts as a recidivist, and during the period of study they were caught 18 of the 66 who escaped, for a recidivism rate of over 27%. In column 2 and 3, they analyze within the EM sample how variables that are available to judge at the time of the EM allocation decision can predict recidivism and evasion. And the result was that the previous imprisonment is a significant predictor of both recidivism and evasion. There are implications in welfare when the EM program is chosen instead of prison, and it is estimated by the difference in the expected values of the decision to go to prison or EM. These measures concern only short-run welfare effects. In the expected value of prison, the first term is the fiscal cost of prison while imprisonment lasts, and the second term is the benefit of society when the defendant is free, that too being period of time. The expected value of EM is calculated in a similar way, but with a lower estimated rate of recidivism, and taking into account that a fraction E escapes from EM. So the first term is the fiscal cost of EM, and the second is the benefit of society when the defendant is free, multiplied by the fraction of individuals that didn't escape. The second part is the fiscal cost of escape, the benefit of society when the defendant is arrested, and the benefit of society once the defendant escapes, multiplied by the fraction of individuals that escaped. If we replace the expected value of EM and the expected value of prison in the equation of the total welfare, the result will be $15,840 by using EM instead of prison, because the EM costs $10 per day, and maintaining an inmate in prison costs $34 per day, and multiplying 660 days, that is the average length of detention, by the $24, that is the difference between using EM instead of prison, we will get a result of $15,840. The main conclusions of this paper are that because of the randomly matched between judges and defendants, many judges had allocated EM to defendants that had committed very serious crimes. Also, treating defendants with EM induces a large and significant reduction in recidivism of 11%. And finally, the use of EM also increases the total welfare.